In this lesson, we're going to look at how to simplify algebraic fractions, but we're going to require to do a wee bit of factorising first. Now, there's three techniques in factorising, and if you're not very good, you can look back at the earlier video lessons in this block on how to do that. But the three main ones you've looked at are a common factor, difference of two squares, and factorising a trinomial or quadratic. So let's look at the top one. 3x plus 6 goes into a singular bracket, that's a common factor. You look at the highest common factor of 3 and 6, which is 3. So 3 comes outside the bracket, and then 3 times x makes 3x, and 3 times 2 makes 6. Difference of two squares. Basically require a square at the start, a takeaway, and then a square number at the end. This always goes into double brackets with a plus and a minus in it. So x times x will give you x squared, 3 times 3 makes the 9. The plus 3x and the minus 3x cancel, which take away the x terms in the middle. Finally, the trinomial or the quadratic, that also goes into double brackets. X times x gives you the x squared at the start. 2 times 3 makes 6, but crucially also adds to give you the 5. Now you have to get the signs right, so negative 2 and negative 3 make plus 6, and minus 2x add negative 3x, make you a negative 5x. Okay, how does this look in terms of algebraic fractions? Well, it says factorise fully, then simplify. Let's look at this first example, 3x plus 9 over 6. So there's nothing you can do there at the moment. There's no x terms that have been multiplied in the top and the bottom to cancel or things like that. What you can do though is you can focus on the top line and you can factorise it. You can look at the 3x plus 9 and take out a common factor. So the common factor is 3. 3 goes into 3 and also into 9. So we'll take a 3 out. And 3 times x inside the bracket will give you 3x. And 3 lots of 3 will give you the 9 at the end. So you can put that over 6. Now if we want to simplify the 3 and the 6, they both divide by 3. So that goes to 1 and the bottom goes to 2. And that's our answer. Now you can have it in brackets or not in brackets in the top, it doesn't really make any difference. Okay, second example, looking at the top and the bottom, there's nothing we can cancel down at this point because you've got an add in the middle. So look at the top and look to factorise. The common factor is what's apparent here. You've got a b in both parts, so take the b out as a common factor. B times b will give you the b squared. And b times c will give you the bc at the end. Now you've got a b plus c there in the top and the bottom. Notice we didn't have any brackets in the bottom, but you can insert them in. And you can see here, I've made them red and I can cancel them out, dividing the top and the bottom by b plus c. Just leaves a b in the top and a 1 in the bottom. That just leaves you with a b. You can write it as b over 1 first, but then just simplify to b. Okay, last example on here. Now, in this example, if we look at the top line, we can take a common factor of v out. But if we look at the bottom, or in fact v squared, if we look at the bottom, we can do 4. 4 comes out of both parts there. So we can factorise the top and the bottom. In the previous examples, we just did the top line. So let's look at the top. You can take out v squared, because there's a v squared here, and there's a v squared within v cubed. If you times v squared by v, you're going to get v cubed. If you put a takeaway in, and then v squared times w will give you this part here. Okay, on the bottom, if you take out a 4 as a common factor, you're going to get a v minus w. And you can see I've scored these out. You can then divide by v minus w, top and bottom, because they've been multiplied. That's going to leave you with v squared over 4. So a bit of factorising first allows you to cancel down.